This week we're going to look at 1-minute interval ASOS data and some of the things you need to know. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. We've talked about ASOS data recently, but it was hourly ASOS data available from the Aviation Weather Center. This week I want to talk about the 1-minute data, which is available for many stations. Now, luckily, Iowa State's Environmental Mesonet site archives this data for you in a nice format. The NCDC archive is pretty difficult to parse, but the IEM does all of that for you, and they make the archive available pretty often. So for example, it's the 8th of August now, and the archive is available up to the 6th of August currently. To use this interface is pretty simple. You select a station. I'm selecting the one that's closest to me at the moment, which is XNA. Select a time range, and I've said that I want all of the variables from the station, the 1-minute data. I want to download it to disk, comma separated, and I don't need station latitude and longitude values. And then I just click Process Data Request. And we get the very well-named changeme.txt file. So I'm going to copy that file over to a folder, change the name, and we'll get started in a notebook. All right, here in a notebook, we're ready to import pandas as PD, import matplotlib.pyplot as PLT, and from metpy.units, we're going to import the units registry, as well as the pandas data frame to unit arrays helper. So pandas data frame to unit arrays. Now I renamed my file XNA ASOS 1-minute. So I'm going to use pandas read CSV since this is a CSV file. XNA ASOS 1-minute.txt. And let's take a look at this file. So we see that luckily it had a header row, and that seems to have parsed sensibly. Maybe there's some unnamed things out here. But for the most part, I would say this is successful. What I want to do is print the columns that are in my data frame. I also want to print the length of that so I know how many columns there were. And we see that I've got 20 columns, including this unnamed column. And some of these look like they have a lot of nans when I saw that header. So let's go ahead and get rid of any columns that are all nans. We're going to do that using drop NA, specifying that we want to work with columns, and how is all, meaning keep the column unless all of the values are nan. Now if I copy and paste this little block of code, we see I'm down to 16 columns. For example, I got rid of visibility 2 and 3. So now if we look at the header of the data frame, this looks like a lot more sensible data to work with. Though you may notice, and what I'm actually interested in today is the pressure data. There's pressure 1, pressure 2, and pressure 3. So why are there 3 pressures? Well, it's time to go to the ASOS Users Data Reference Manual from weather.gov, media ASOS aum-toc.pdf. In the pressure section, we can read about how the pressures are logged. And what we find out is at Towered airports, there are 3 pressure sensors, and at other airports, there are 2 pressure sensors. If their difference is less than 0.04 inches of mercury, they are considered to be valid compared to each other, and the lowest value from any sensor is reported. And there's what all the equipment to do this looks like. So we want to replicate that, let's say. So I'm going to create just a pressure data series, and that is going to be out of my data frame, looking at the press 1, press 2, press 3 data series. I want the minimum, and I want the minimum in a columnar respect. So now I've got what ASOS would consider to be the valid pressure. Now it's assuming that all three pressure sensors are working. I'm not doing any QC on that data right now. And we'll see if that's a valid assumption or not. The other thing that I know I'm going to need to do is convert string date times into datetime objects that we can work with nicely in Python. And that was a valid UTC data series. We're going to use pandas toDateTime method and call it on that same data series to get those into date times. So now if we look at our data frame again, we're getting to be in relatively decent shape here. But I might be able to drop a few more things. I don't need station name, this visibility code, and precipitation type. I'm just interested in numerical data. I'm going to call df.drop, station name, vis1nd, p-type. Axis, these are again columnar, so columns. I don't really like using the 0 and 1. It doesn't read near as nicely. And I'm going to do this in place true. Now we have a really nice compact data frame with the information I want and not a lot of extra data. What we don't have though are units. And we know that I'm going to want units to do math, especially because these are in things like degrees Fahrenheit and inches of mercury. I want to convert those into some units that we normally do our science in. All right, so let's make a list, or in this case, a dictionary of the units. For example, valid UTC. What's the unit on that? Well, we don't need one. It's a time. Tempf is going to be degf. And these are the pint registry names. Dew point is going to be degf. SKNT, our wind speed in knots is going to be knots. Direction is going to be in degrees. Gust direction, degrees. Gust speed in knots is knots. You can use the singular or plural. I'm just going to stick with the singular. The vis1 coif is going to be in miles or mile. You can't use SM for statute mile. All right, precip going to be in inches. Press 1. Then inches of mercury. And I'm going to copy and paste. Because we know that pressure, press 3, and press 2 are also in inches of mercury. So now we've got our dictionary with units set up. It's time to apply it. To do that, we're going to use the pandas data frame to unit arrays helper on our data frame. Our column units parameter we're going to set to df units. And now we have a dictionary of united arrays instead of a data frame. So finally we can make a plot. I'm going to use plot.subplots. Make my fig size something like 15 by 10. Going to plot with our valid UTC time. And I just saw here that I missed a parentheses there. So we'll rerun this, all of this before we actually make our plot. And press 1. And I'm going to convert that to hectopascals. It's always a good idea before we get too deep. Just go ahead and make sure that that works. That looks pretty good. So now we're going to plot, press 2, 3, and pressure. And pressure, I'm going to make a black line that's partially transparent. And what we see is that all of these sensors are the same trend. There's a slight offset. In fact, if I comment out the pressure, the minimum, we see that press 1 looks to pretty consistently be the lowest, while 2 and 3 are basically right on top of each other. But we know that the way the ASOS works is it's going to take the lowest of those values as long as they're all within 0.04 inches of mercury. But we're not looking in inches of mercury. So 0.04 inches of mercury, I want to know what that is. So I'm going to convert that to hectopascals. We see 1.35. Considering that we're only looking at a range of 2 hectopascals here, these are definitely well within 0.04 inches of mercury. So ASOS is picking up the lowest pressure sensor, which generally is pressure sensor 1. So I hope that you found this useful. The 1-minute data, though it isn't available everywhere, is a much more granular source than the hourly data, and can really be a lot more useful for our meteorological explorations when we're looking at things like frontal passage and other relatively fast events. I hope you found this useful, and I'll see you on next week's MetPy Monday.